All right, we'll go to through the answer to question 2 here. So we've got a 200 millihenry coil in series with a 15 ohm resistor and in series with a 30 microfarad capacitor, and we're looking for the total current and the power angle of this series RLC circuit. Okay, so the first thing we're going to have to do is convert these all into like units so we can combine them, which is going to be our ohmic values, and for that we're going to use our formula of XL equals 2 times pi times frequency times inductance, and XC equals 1 over 2 times pi times frequency times capacitance. Okay, so for our 200 millihenry coil, 2 times pi times 60, which is our frequency given to us in the question, multiplied by 0.2, because this is given to us in millihenries, and in the formula we're looking for it in henries, so I've just converted our 200 millihenries to 0.2 henries, equals 75.398 ohms. We'll do the same for the capacitor. 1 divided by 2 times pi times 60 times, we've got 30 microfarads, which is 0.00003 farads, bracket equals, so we got 88.42 ohms across our capacitor, or created by our capacitor, 88.419 ohms. And then we can combine those. Now, we're just going to do this on the, I'm going to show you the shortcut mode. If you're not familiar with this, if you got a calculator in the R theta mode, right? So if it's one of these sharp calculators, I'm just going to reset it here and get it back to, so when it's in normal mode, if you go mode 3, second function 8, you'll see this little R theta pop up in the corner, and that will allow you to add values vectorially. So instead of breaking it all down into horizontal and vertical components and then doing Pythagorean theorem and everything, we can just add all of these values, and it works whether you're adding resistances in series or currents in parallel, doesn't matter. It works using this method. We got 75.398 ohms, and then you hit this DMS button at 90 degrees plus 15 ohms at 0 degrees plus 88.419 ohms at 90 degrees negative, because this is a capacitor, and that when we total that up, it gives us a total impedance of 19.863 ohms. We have 100 volts applied. 100 divided by 19.863 gives us 5.034 amps of current flow. I did this out of order. I'm just going to go back through that original equation. 75.398 at 90 plus 15 at 0 plus 88.419 at 90 negative equals, this gives us our Z value, our impedance value, and then if you hit second function exponent, that'll actually tell you the angle that that's happening at. So this is happening at negative 40.96 degrees. So negative 40.96 degrees, which means it's overall leading. It's going to make sense because our ohmic value for the capacitor is larger than our ohmic value for the coil, right? So there we have it.